Hi everyone. Today let us learn some more examples of writing chemical formula. So first example is going to be ammonium fluoride. So the symbol of ammonium is NH4. So as I told you in the last video, if we um, add a proton, that is H plus, to ammonia, that is NH3, we get NH4 plus. Okay, so that's why the valency of ammonium is first of all a polyatomic ion, and its valency will be plus 1. Okay, and then fluoride, we are considering the fluorine atom, so the it is having the symbol F. So now talking about the valency, ammonium is having plus 1, and fluorine, because it is belongs to group 17 in the periodic table, so all the group 17 elements are having minus 1. So crisscross the valency, the formula of ammonium fluoride is going to be NH4 plus. So here, because if you observe, valency is plus 1 minus 1, right? So it is neutralizing. So hence the formula of ammonium fluoride is NH4 plus. Okay. Now let's go with the second example. That is going to be lead chromate. Okay. So now lead is a metal, and the symbol of lead is Pb. Okay. And then when we talk about chromate, see, chromate is obtained from chromic acid. Formula of chromic acid is H2CrO4. Okay. Now from H2CrO4, Cr is chromium, and we have O, that is oxygen, and H, we know it's a hydrogen. So if we remove the H2 hydrogen, okay, so what will be the valency? The valency on CrO4 will be minus 2. Okay, and lead is having a valency of plus 2. So here again, similar to the previous example, plus 2 minus 2 will cancel out. And if I crisscross the valencies, then the formula of the compound will be PbCrO4. Okay, this is the molecular formula of lead chromate. Okay, it's Cr. It's not G, it's Cr, capital C and small r, and capital P and small b. Okay, so as you're already aware, whenever writing symbols which have two alphabets, the first alphabet will always be capital and the second alphabet will be small letter. So now this is going to be the formula of lead chromate. So now in exam, students, they would have given the oxidation state. Okay, because some metals or some elements have variable valency. Okay, so if we talk about elements like hydrogen, sodium, potassium, oxygen, okay, they're all having a fixed valency. Their valency will never change. Hydrogen, if we take, its valency will be always plus 1 or minus 1 if it is reacting with a metal. Similarly, if you talk about oxygen, it will always be minus 2. If you talk about potassium, it will be plus 1, calcium plus 2, right? But some metals have variable valency, means their valency depends on the other atom, right? So many times it happens, isn't it? That some metals will react differently with different elements, right? So that is when they become variable or they attain a variable valency. Okay, so now here lead, okay, is one such example wherein that's why they have mentioned the oxidation number within this bracket. So when I say lead 2 andre, it means that I should be writing valency as plus 2. Okay, and we all know lead is a metal, so lead will always be giving electrons. So that's why it is electrovalent. Sorry, electropositive. So electropositive, so that's why it is plus 2. Okay, so this is one hint for you to understand how to write the chemical formula with oxidation number given. Okay, so let's take some more examples like this. Silver chromate. Okay, now silver What is the symbol of silver? Ag. Capital A, small g. Okay. Chromate. CrO4. Same. Chromate CrO4. Okay. Now coming to the valency. Silver always donates one electron. So it is plus one. And chromate, as I already told you, it's from the chromic acid. H2CrO4 is chromic acid, and from that, if you remove two proton, it will be the valency on chromate ion will be minus 2. Okay, so now if I crisscross, what will be the formula? Ag2, right? CrO4. So this is the formula of silver nitrate, sorry, silver chromate. Okay, Ag2 CrO4. Okay, so now let's go with the third example. Sodium bicarbonate. Okay, sodium bicarbonate. Symbol of sodium we all know, Na. Now bicarbonate is HCO3. Okay. Now what is the valency of sodium? Plus 1. And valency of bicarbonate is minus 1. So what if I crisscross, what will be the formula of sodium bicarbonate? NaHCO3. Now, sodium bicarbonate is nothing but common name is baking soda. You're already aware, right? So, whenever we bake cakes and other bakery items, so we are making use of sodium bicarbonate only because it will produce carbon dioxide and makes the food item fluffy and also spongy, okay, and soft. So the cakes that we eat or even the bun bread that we eat is very soft and spongy. That's because it produces sodium bicarbonate. When it is heated, okay, it produces carbon dioxide gas. So that carbon dioxide gas is filled within the bun or the bakery item. Okay, so that's how the bakery items are very fluffy and spongy. Now this is the formula. Okay, sodium bicarbonate is NaHCO3. So now let's take one more example. Sodium um, bisulfate. Okay, now the next example is going to be sodium bisulfate. What's the symbol of sodium? Symbol of sodium is Na, and bisulfate is HSO4. Okay, sodium symbol of bisulfate is HSO4. Now, HSO4 is, see, whenever you get a word like this, bicarbonate or bisulfate. See, if you're writing carbonate, what would be the formula of carbonate? CO3, right? So when you come across the word bicarbonate, then you'll be writing HCO3. Similarly, sulfate means SO4, 2 minus. But when you're writing it as bisulfate, then there will be only one hydrogen removed. So that's why it will be HSO4 minus. And understanding. So this is how we write for formulas, sorry, symbols whenever there is bi involved. Okay, now the coming to the valency. What is the valency of sodium? We know it's plus 1 and HSO4 is minus 1. So many it is like this, students. Say you have H2SO4 is sulfuric acid. Sorry. H2SO4 is sulfuric acid. Now, out of this two hydrogen, okay, now one hydrogen is removed. So what does that becomes? That is called as bisulfate. Now, if the second hydrogen is also removed, then what will be the charge and what will be the name of the polyatomic ion? It will be sulfate ion. Are understanding? Just like that, even if we write for carbonate also, the previous example, we have H2CO3, carbonic acid, right? Now, if I remove one hydrogen, what will be HCO3? It will be bicarbonate. Now, if I remove this hydrogen also, what will be the polyatomic ion? Carbonate. Okay, and if I retain this H, so it will be bicarbonate and the valency will be -1. But if I remove this hydrogen, it will become carbonate and the valency will be -2, because every time you're removing one hydrogen, one extra charge goes on adding to the polyatomic ion. So that's how it is. Okay, so that's why now the charge of carbonate is -2, but bicarbonate is -1. Similarly, charge on sulfate is -2, but here what is given? Is given bisulfate, so that's why -1. Right, so now what will be the formula of sodium bisulfate? It will be NaHSO4, because the charges are cancelled out. Okay, so NaHSO4 is going to be the formula of sodium bisulfate. Now similarly, let's take another example, cupric 2 nitrate. So in this cupric 2 nitrate, he has given the oxidation state. Okay, it's a cupric 2 nitrate. So 2 is telling me how many electrons copper is losing. So how many electrons copper is losing? Copper is losing 2 electrons. So that's what will be the valency. Valency will be +2. Now first let us write down the symbol. Copper, Cu, capital C, small u. Nitrate is NO3, capital N, capital O and 3. Now coming to the valency, is already mentioned, it's 2. So as I already told you, student, whatever is given within the bracket, it's called as the oxidation state. Means it tells us how many electrons the particular metal is losing. Metal always lose electrons. So that's why copper is losing how many electron? 2. So because it is a metal and losing, so +2. And when we talk about nitrate, what will be the charge on nitrate? -1, because it is HNO3. When you remove one hydrogen, so NO3 -1. Okay. So now if I crisscross, the formula will be CuNO3 twice. Okay, this again follows the same rule that whenever you have a polyatomic ion, it's more than one, you should always put it in bracket. So this means that copper is the central metal and two NO3 groups are surrounding it. Okay, so this is the formula for cupric nitrate. Okay, next one more let's solve, that is magnesium phosphate. What is the symbol of magnesium? Symbol of magnesium is capital M small g, and phosphate is polyatomic ion and it's having a formula PO4 3 minus PO4. Okay, now valency of magnesium, it's a it's a group 2 element, so +2, and phosphate is phosphoric acid H3PO4. 3 hydrogen you remove, so what will be the charge on PO4? 3 minus -3. So if I crisscross, it will be Mg3PO4, the whole bracket and twice. Okay, because there are more than one phosphate group. Whenever there's more than one polyatomic ion, then we are writing it in the bracket, and Mg is having a 3 now. I mean, we are crisscrossing the valency charges. So Mg3PO4 twice is the chemical formula of magnesium phosphate. Okay, so like this, you have to understand the or know the symbol thoroughly and also know the valency. So with these two now, you can write any kind of a problem. Okay, so that's all for this video. Thank you.